Hello, everyone. Welcome to another Wolfram language design review, part of our incremental language design series. We have a few topics here. First, tree visuals. This is presumably still for 13.1, is that correct?
Yes.
Okay, so those look nice to me. Those ones look nice. Now, what's this one? That one, tree element none, as opposed to an unlabeled tree.
Right. Unlabeled tree sets a bunch of other options.
So let me just understand, if I were to try okay, why did that do what it did? Because that was just wrong. I was just wrong.
This PR was just merged yesterday.
No, I mean, multiple things are wrong there. The aspect ratio is wrong, and I don't have to do this nonsense, do I? Do I have to do that nonsense? Because I shouldn't have to do that nonsense. That's not the default.
It will look exactly like above with the green circles.
And by the way, why didn't that work? Unlabeled tree should take the same options as tree takes, shouldn't it?
Yes, and that's fixed and right now.
Oh, okay,
right.
So I basically can't see this right now. Let me ask about aspect ratio, though. What's determining that?
It's the automatic aspect ratio from graph.
Can somebody explain how that's determined? Because I'm not sure the heuristic is right for trees.
I don't know.
I don't think there is. I mean, right, we had Charles last time to mention it, and he's like, oh, I'd have to look into it. So
well,
it's sufficiently complicated that I don't think anybody can immediately answer the question.
Okay, let's try to get an answer to this. I mean, in other words, or let's figure out what we think it should be. I mean, what heuristics can we imagine for these aspect ratios? I mean, in a sense, what we're trying to do, okay, what are we trying to achieve? We're trying to achieve some density of nodes. What the heck are we trying to achieve?
Maybe it's worth considering the cases where it's unintelligible and then just trying to avoid those.
Yeah. Well, so for example, let's do a tree that just has a zillion nodes coming out. What would be how would I generate one of those? A one level tree.
Do nest tree and change the 3 to like 7.
Nest tree, what do I say?
Like that input below.
Oh, I see. No, I didn't mean that. I mean a single node.
You say nest tree of range of 1,000.
You just want a single node with a ton of children?
Yes.
Do like tree of range of 1,000.
Oh, I see. It elides like that. That is not a good elision. That elision symbol is like from version 1.
Yep.
We have a talk about this.
We created a design ticket last time for this
to improve that. Okay.
For 13.1.
How do I get this to try and show the thing? I mean, I think that's a little bit, not tall enough, probably. So if I give an aspect ratio here. Oh, whoops.
In the tree, yeah.
In the tree, arboreal aspect ratio. That's not very good either. So what do we think? Where? I kind of think that looks pretty decent. Whereas, what do other people think? I think that looks better than this. In fact, I think one criterion is, by the time the lines are crossing over like that, it's bad news.
So maybe try an example where...
Well, they are crossing over a little bit, even in the 1/4. At least that's how it looks to me over Zoom.
Where?
The 1. The one, okay, now they're not.
Well,
Now
yeah.
they're not, but at the original size.
Oh,
there's-
okay, there. Yes, okay, it did. But somehow that looks significantly better, that aspect ratio of quarter. Christopher,
So
what were you going to say?
try the harder case. Just do nest tree of range of 100, comma 1, comma 3. I'm not sure if that'll be too big, but
1, comma
maybe-
100, comma
no,
range.
range of 100 ampersand, comma 1, comma 3. I'm not sure that's too big. Maybe do 25 instead of range of 100. Yeah, try something smaller.
Wait a minute, is that going to well, that's absolutely hopeless.
Well, I'm just trying to make something that's a bit deeper, but also has these very high degree things. That's
Right,
like
and that
You
true.
can
clearly was-
specify
Why is it
like
totally
trees,
flat?
backtick, visualization, max children, if you want to control the elision.
No, I don't care about controlling.
But
the-
actually, in that case, why did that's probably just a bug that it showed up as like almost totally flat.
This is wrong. I mean, okay, so does nest tree take an aspect ratio option or not?
Mhm.
Okay, so this is clearly the wrong heuristic here, right? The 1/4 is actually looking fairly decent on this one as well. So why does 1/4 look decent? What is the, I mean, is it, okay, here's
I
a
think
criterion.
it's because these are relatively shallow trees, right? I mean,
Okay, I've got a criterion for you guys. The angle at a tree node shouldn't be more than such and such.
Right. We'll try the really tall tree because that's the converse thing. So let's just see what that looks like. So just do nest tree of list 1 or something like that, comma 1, comma 10, or maybe more than 10, 100. Well, that
so
may be
that
a very-
case it handles fine. What if
Yeah.
you do like 1, 2?
right.
Oh, that's just, okay.
I mean 2 to the
Well,
10.
that's
So
with an
that's-
aspect ratio, that's with an aspect ratio of 1/4.
Oh, right.
Yeah, well, that's a fail.
Yeah.
So it seems like there's some problems with very wide graphs. I mean, if nothing else, it seems like there should be maybe there should even be a
Minimum
bound
aspect
on the
ratio.
maximum width. Yeah, it seems like they can be arbitrarily tall, but they probably shouldn't be arbitrarily wide. I don't know.
Right. See, the point is that for ordinary graphs, if I do a path graph, okay, Charles wants it to look like that, and he's right. Okay, but for trees, you never want it to look like that. For trees, there should be a minimum aspect ratio, I claim.
Except vertically. They
No,
can be
I'm saying-
arbitrarily narrow, but not arbitrarily wide. Because as we saw with the case where you did nest tree of just list 1, that just looks like a vertical path graph. And that's
Yeah, I
fine.
know, but that's a very large aspect ratio. which
Yeah,
is
I'm just
correct.
saying it's bounded on one side but not the other.
That's correct. Yes. So I'm claiming it never should get smaller than 1/4. See what I'm saying? Ian, you understand what I'm saying? Because this is clearly wrong. Right?
I'm
Ian?
not sure a quarter might be even too might be I mean maybe it can be a little wider than a quarter. I don't know. Maybe we need some maybe there's some counter examples.
But I think the first cut, 1/4 should be the minimum. Ian, are you here with us?
Yeah.
I mean, do you disagree?
With the word minimum makes me nervous. Like, exactly how are we going to compute the aspect ratio in other cases? Like, I could.
Well, I mean, if
I
nothing
know,
else,
I'm
you can
saying-
just
I'm
use
saying.
if nothing else, you can just use whatever the automatic graph one is, and then change it if it's less than a quarter. I mean, that would be a kind
what
of
I'm
dumb
saying.
way to do it.
That's what I'm saying. The first step would be that in order to avoid this case, right? Because as I say, what Charles has done, which makes perfect sense, given that he's got path graphs, right? But you cannot have a graph that looks like this. Right? Your thing always has to have a height.
Right.
Right?
Unless
the default
unless you're
layout.
rotating your tree. Right. I mean, right.
Oh, yeah, we have to be careful about that. Yep, we have to be careful about that. Right. But so, okay, so my next claimed criterion is this angle criterion. What do you think of the angle criterion?
Seems reasonable.
Okay. So can you compute that angle easily? Can you compute, look, what you're going to have, let's take one of these trees, okay, here. All right, so who can think through the code quickly to compute the angle distribution in this tree? So presumably I can get the coordinates of every node. And what I'm doing is for every node, what are the actual coordinates of its children? And then I take some kind of arctan or something to get that angle. Do you understand what I'm saying?
You would. So we don't have a way to extract like annotation values from trees currently. You could convert this to a graph and pull the coordinates out of that.
Okay. Okay. So now what do we recommend here?
Are you trying to get the span of angles? Like, are you trying to get?
I'm trying to get a
the furthest
histogram.
left one is like this. No, but by angles, do you mean the absolute angle, like this edge is almost horizontal, or do you mean the relative angle, as in this edge is pointing this way and this other edge out of the same vertex is pointing the other way?
You know, I have to say my angle criterion, I think, is blown up by this picture. Because this picture, these things are very splayed out, almost 180 degrees, but it looks right. Okay, what do we think about the aspect ratio of this tree? It seems to look pretty good to me.
Yep, I like it.
So, I mean, if we say, let's just take this and let's just, for the hell of it, I mean, as I said, I think it's a winner right now. Really, what did that just do? Okay, compare and contrast.
Well, actually, I kind of like the aspect ratio 1.
Yeah. It's a deep tree. And that, you know, looks like some kind of hanging gardens type thingy there. Whereas this, I kind of do prefer this one. So, okay, so let's understand how we would learn, you know, which of these is better. I mean, the other thing we could do is look at some published trees and see what people have tried. They probably did a bad job. Never mind that idea.
So I'm curious, if we take one of our really bad examples and give it the options to display left to right, do we get something reasonable looking, or do we get a different fail?
One of these, for example.
Yep.
Okay. How do we say to display it?
Tree layout arrow left.
You get a different fail.
Yeah.
Wait, no, that's the same fail. You know what I mean?
I suppose, yes. It's the same fail. It's just yes, rotated 90 degrees. But it's a bit disappointing. We didn't do better.
Yeah. So I mean, in this case, if I say aspect ratio, the aspect ratio is post rotation. So I want to say aspect ratio 4 here. Is that correct?
I believe so.
Okay. Much more reasonable. But so now if I went down to 2, for example, yeah, I mean, that's getting progressively better, probably. But we never want to get a situation where I claim it looks really bad if you have too small an angle. Okay, so here's my criterion here. So let's try 1 here. Yeah, I don't know, that's sort of okay in this particular case. Okay, so I'm going to make a claim that even if you take a thing like this, well, let's take tree. Range of 5, for example. Okay, so now let's go ahead and okay. Okay, so
it
I
seems like there's
claim
an intermediate value that's good, because if you make it too tall, I mean, even
Yeah,
like what you
too
have there,
tall, it's
aspect
no
ratio
good.
1,
that looks
and
pretty
too flat, it's also no good.
right. So what we're seeing here is, for this case, values between, let's say, I think that's about as low as you go, 0.2 to
I'm
about,
not sure that's as low as you go, because that's I mean, you saw that example above where it had just those 2 children and it was super, super wide.
yeah. Okay, but I understand, but but I mean, I'm saying for this particular tree, it's between like 0.2 and 0.5, I claim. I mean, it's sort of looking okay there, but if we make it pointier than that, it looks wrong. Okay, so what is the criterion? So I think the criterion is, what causes this to look wrong?
I think that one, honestly, I mean, there's the problem of interpretability and there's the problem of ugliness. This one is just ugly.
Yeah, I agree, but why?
I mean, partly I think it's because the distance between the children and the parent is so far. Like, you can't really have them the same, like,
Yes, okay.
field of view. Like, you
Can
follow
we
the
see?
edges.
Can we just see if Jeremy happens to be available? Maybe he would have an immediate reaction to this. Somebody do that, please.
Yeah, I can check on that. We also have Billy here right now.
Oh, Billy is here. Okay. Well, does Billy have an opinion about this?
Yeah, I agree. The parent seems a little bit too far away. It's like stretched
Can
out.
you
Like
can you express, a reason for why that doesn't look right? In other words, between this, which clearly doesn't look right, that's too flat.
too flat.
Yeah, but so, design wise, talk about what, it's like, what makes one of these look right versus looking wrong? It's kind of almost a physicality of the thing. If you were making, I don't know, that doesn't seem. Go ahead.
Yeah, and it's like it's almost like you kind of want to be able to control the bottom layer too. So if it goes up a little, then they kind of come in, because right now they're sort of stationary, so you don't get.
What do you mean? I mean, this is the control we have right now is pure aspect ratio here. This is so for 5 members, for 5 outputs, we are, okay, so let's record this. 5, a 5-membered tree. We think we can go between 0.2 aspect ratio, between 0.2 and 0.5, we said, right? Is that right?
Yep.
0.2 to 0.5. Okay, so now
I think it'll be the same if you have a 5,000 member tree.
Okay, let's check that hypothesis. Okay. Okay, we're not going to do 5,000, but let's do 30 or something here. Okay. Oh gosh, can I reset this to actually show 30?
Yeah, so do trees backtick visualization max children? The option as an option. Visualization max children.
How are we actually presenting that to users?
It's undocumented.
I understand that. What are we going to do to make it not undocumented? Because it seems like a useful thing to have. When we have that elision mechanism, we need a way to get around the elision mechanism.
Mm-hmm.
Right? So what will be an analogous option somewhere else? And then we need to name it here and put it in.
Max items.
Yeah.
Yeah, it is. It's like max items, isn't it? But max items also does not just govern display, or does it? Are there cases where it just governs display?
Yeah, data set.
Data set, for example.
Right,
Okay.
it's how big your page is, but it's not, doesn't affect anything about the data itself.
I feel like max items would be unclear because it's per. It's
Yeah,
per.
I mean, I don't think it's the right name for this usage, but
Okay, so what, Ian, you've said, do you use the term children
What?
Yes.
in what function?
Tree children.
Okay, so this is really like max displayed tree children. Is that right?
Maybe max
At
display
each
children
node,
with the-
right? So
Yeah, so it's an option. Oh, I see. Max displayed children. What are you saying, Christopher? You had a.
No, I was just cutting the tree children because the tree seems unnecessary.
I think that's a reasonable option. Anybody got a different suggestion? And that will be an option at every tree in every tree element, right?
yeah, so
Yeah.
right now this globally controls all nodes. I guess it could be made like per node.
Well, you should do the same jazz that you're doing with your all arrow blah 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 thing, I think.
Yep.
Okay, so here Christopher seems to be right that this is no more. This doesn't help. Whoops.
I think I have the impression that I like seeing as many possible lines being 45 degrees.
Yes, actually, Stove on a live stream says, looks like if you think of that tree as a triangle, then the top angle should be between 60 and 120. They say.
Well, that was the thing you were saying earlier, but then with that bigger one we saw that there were some edges that were like almost 180.
Yeah, I know. So let's look at that one. Look, I think in some sense, no, that's a nonsense thing. I was going to say, in some sense, you want the mass. If I think about this as a mass distribution, okay, let's talk about a different thing. Let's talk about this as a what on earth am I saying? As a mobile, one of those things you hang up that kind of wobbles around. You know what I'm saying?
Yep.
What, I mean, again, I may be completely crazy here. If that's but this looks a bit like one of those. And if I then say, maybe this is just a nuts thing to do, but let's try.
That's also because that's a relatively balanced tree, which it doesn't have to be.
Yes, that's true. That's true. And I have a bad feeling that these are these things that look very much like that tree. Okay, this was an unhelpful direction, I think. Although it is sort of interesting that many of these.
I think the key takeaway is we need umbrella-shaped vertices.
Well, I mean, there is some elegance to these things. They have a certain, well, of course, that's just because they're basically balanced. Never mind. Okay, so let's take this example. Let's look at this example and let's see what it would take to make it look bad. Okay, so that aspect ratio, I think you're definitely right that this aspect ratio is better than this aspect ratio. Why? Okay, let's make a manipulate out of that. We'll do it at a decent speed.
I think we have two competing ideas here. One is the global aspect ratio of the thing, and then the other one is the local aspect ratio that we see in collections of children. And I think this second one looks better because there are many local 45 degrees that we see here. And then we accept a few large angles.
I see what you're saying. I see what you're saying. You're saying if we look at the distribution, that it will be peaked around 45 degrees for the local angle. You think it's the local angle that matters, not. I see, that's an interesting theory. Okay, so that looks terrible. Okay, so let's go. So can we write the code? Okay, so here we go. My gosh.
Yeah, I think that actually that sounds right. I mean, it seems like, yeah, if you've ever seen one of these graphs, I don't know if you have any that really do this, or it just has lots of these really wide ones. It's just a bunch of horizontal lines. It's really hard to tell where any of them are going. It's like a maze.
Well, but so okay, so what we need, and maybe somebody could just write this code, is the thing that computes the angle distribution for one of these layouts. And then what we would do is we would try, okay, so then we could compute, okay, how easy is it to compute on the fly given a tree, can you compute for aspect ratio A what the angle distribution is? Is that an easy thing to do? So that we could then we could then try and, tune the aspect ratio to achieve a peak.
If you have the layout, I think that changing the aspect ratio will just like kind of linearly change all those angles, or not quite linearly, but like by the cosine or something like that.
I see what you're saying. So you're saying that we can shift the peak, that all that's going to happen is we've got an initial histogram, and by changing the aspect ratio, we are merely making a simple deformation. Yeah, that's obviously correct, right? That we're changing those angles in a simple trigonometric way, and they're all independently being changed. So then the question is, what is the original aspect ratio distribution? What is the original angle distribution? And then it's going to be some wiggly distribution that has some outliers. And then we're going to have to ask, how do we move that angle distribution to be most, I don't know whether we want the greatest mass around 45 degrees or whether we want quantiles near 45 degrees or what? See what I'm saying? I mean, I really would like to, can somebody see how to do this? How do I get, given a particular vertex, here's what I would do. So given this graph, let's take that graph here, line 40. Let's say line 42, for example. Okay, so here's what I'm going to do. So for over the vertex list, okay, let's do graph angles. Graph G, given the vertex list, for every vertex, we say
annotation value.
What do you want to do?
Annotation value
of what?
Of list G, comma the vertex, comma vertex coordinates.
I might be learning better how to use annotation value. Okay.
I think you can also use graph embedding for that, but yeah.
Yeah, that's what I was going to do. I was going to say graph embedding, but it's okay.
Oh, I don't know if graph embedding is going to recompute something, but yeah.
Well, no, we could do graph embedding once. Okay, so go ahead. What were you saying, Ian?
In the first argument, list G, comma slot. Second argument, vertex coordinates.
Okay, but that's getting
non-string vertex coordinates, right?
Yeah. Okay, right, but that's not getting me quite what I wanted, because what I was
so then you want to do adjacent. It's either just do you can use vertex out components, or isn't there also adjacent vertices or something like that? Or adjacency list. That's what it's called. It's like slightly better.
Adjacency. Why would adjacency list be better? Because what I was going to do is
you can omit one argument, but it doesn't matter. You can also use vertex out component.
Okay. Of G comma hash on the vertex list, and then that's a vertex out component. That's a one level, but no, I just want the one level.
No, that's infinite levels. You got to do it. Adjacency list would have done one level.
Oh, I didn't know that. What is adjacency list? So adjacency list for one vertex?
I think so.
Just of the graph.
No, I don't want to do it for the graph. I want to do it for a single vertex, because I've got to go over this. Look, what I've got to do is I've got to get the vertex out.
You can put the vertex in the second argument then.
Okay, hold on. And we say if length of that is less than 2, then nothing, because we don't have an angle then, right? Otherwise, we want to say those two components, we want to say we want to get the annotation value of those two coordinates. Oops, and then what we want to say, actually, we don't want
You want to transpose it, and you want to take the mean of the y's, and you want to take the min max
No.
of the.
Well, I was just going to take, look, we've got to get the original vertex as well. So we've got to take, in addition to that, we've got to have that, and then we've got to say, we've got to have the angle between, oh, I see, you've got the min max of those. Yes, I get it. So you're saying of these things here, we've got to say, and that's going over vertex list.
Steven, I put something in the chat. Not sure even whether it's right or not.
Okay. Thank you. Oops, what happened? Oh, I see.
That's the whole thing.
Okay.
But maybe get rid of the yeah.
Yeah, I don't want the module. Cool. Okay. Let's actually make our histogram happen outside of it. Okay. So let's take our original tree here. Which was, let's do our aspect ratio. Okay, so as a function of aspect ratio, so we'll take line 26 and let's go ahead.
Does the aspect ratio actually change the embedding or just the plot?
I assume it changes the embedding, doesn't it? That's a good question. Does anybody know?
I think it doesn't affect the embedding.
Well,
It'd be easy to emulate it though, because you could just multiply that emb variable by the aspect ratio, or by, yeah, you know what I mean.
Okay, let's make a histogram of these. Interesting.
You maybe divide by degree.
Yes. Well, isn't that interesting? Okay, let's give it a few more bins. It really likes that angle, whatever the heck that angle is.
Maybe
Okay,
30
now,
degrees. Yeah.
let's try changing the aspect ratio.
Maybe it's already optimizing for something similar to what we're talking about.
Look at this. What the heck is going on? This definitely changed. This changed the distribution. So it does care. Okay, let's do a very basic thing here. If Nick thinks his code is right. Let's take this thing here. Let's take something very basic.
Why don't you take one that's going to give you a very extreme, ridiculous result if you want to see if the code is right?
Okay, I was going to say here, let's just make a table of these with aspect ratio A goes from, let's say, 0.1 to 2 in steps of 0.1, for example. Well, okay, so this is indicating that they're identical.
Which is wrong.
Well, which is wrong, but that suggests that something is happening. Oh yeah, I'd forgotten vector angle, which is the obvious thing to use here. Nick, what did you do here? So let's just take a look what you did.
So for each vertex out component, right, I compute subsets of each of edges and make a vectors, like a pair of each pair of vectors, I just compute an angle between them.
Okay, so you're not computing the maximum splay at a particular node. You're computing, so in other words, you at this node
I think
here.
he's computing all the splays and then
Yes,
he's taking
right.
the max.
Oh, is he?
Yeah, maybe we should put an act. No, I'm not putting any max there. Maybe we should put maximum for each vertex.
So, so what you're computing is every one of these contributes to the histogram.
Yeah, every pair.
Okay, I claim, you know what? I think we want to know the angle relative to the vertical. I think that's what's more relevant. I think it's the angle of every edge relative to the vertical, I claim, rather than the splay angle. My new hypothesis.
Okay.
Well, actually, those are probably directly correlated because it's going to be pretty much symmetrical, right?
If it's a balanced tree.
I guess, yeah.
Okay, Jonathan has to leave in a few minutes, and I do too. So let's take a quick look. Okay, so we've defined the problem here. We clearly,
So,
I think.
can you say if you're okay with the new like styles?
Yes, the answer is yes. I think they look good, but I think you should put a minimum aspect ratio in if you can. Okay, and I think this option we just discussed for the children display is also good. But I think the styles look good.
All right.
But I think we do need to fix this aspect ratio thing. And I think the first step is this minimum, and maybe you could do a little bit of investigation of this histogramming thing. Okay, can we look at proof object for a minute, please? Okay.
Yes. So there are two parts here. One is the change that Nick is proposing, which is this first part, and second are improvements or extensions. And so I think the important part is this first part.
Okay.
And
but so wait a second. Is it just to give me some sense here?
Mm-hmm.
This exists versus for all. What is
Yes.
this? What's the improvement proposal here?
So the improvement, it's more bug fix, because previously FindEquationalProof ignored basically existential quantifier, or other way around. Everything was an existential quantifier.
I thought everything was a universal quantifier.
No, it was actually existential. It's like if you put a for all, it was treating it as constants, and Waldmeister was treating all those variables as constants. Because in Waldmeister, it is specifically, there's a strategy when there's a grounded, well, there's a like not grounded theorem. It tries to
So
prove
wait a
it by
minute. So what would
refutation.
this effect would this have if somebody left out the for all in the proof that in the theorem they're trying to make? You're saying, I mean, that like the typical example I use, prove P dot Q equals Q dot P given Boolean algebra. You're saying that right now, when I say prove P dot Q equals Q dot P, that is not quantified. Is that correct?
But basically, if there's no for all, it's just a constant. It's the same as specifier exists, existential quantifier.
Okay, so but the theorem I think I'm proving isn't the theorem. I mean, I'm proving the wrong theorem. Is basically what you're saying. In that case, if I think I'm proving the general P dot Q equals Q dot P, I'm actually not proving that, although it doesn't matter in this case.
Yeah,
Is that right?
basically that's how it was before. We were
Okay,
proving only the special cases. And if you prove it by refutation, the proofs are in general much shorter.
Okay, token event proof graph, that seems like an obvious win. I mean, that's basically emulating what was in the MetaMath post, right?
Yeah, I just
Wait,
copied
sorry,
out the code.
So does the quantifier thing, how does that relate to full simplify? I mean, like, does full simplify, is this also a problem with full simplify?
A little bit. Simplify uses Waldmeister only when there's assumptions and explicit axioms.
Yeah, it requires for also. That's
in the assumptions.
In the assumptions, yes.
Yeah.
But the thing that Nick is pointing out is that in the target that you are proving, there's an issue about whether you include the for all.
Right.
Right.
You
So
don't include the
for
for all.
simplified, there is no such issue. For simplified, I don't think there is. So
Why isn't there that issue? In other words, in simplify, when you prove P dot Q equals Q dot P, you can perfectly well assume that those are
general, yeah. So they are generally quantified. So if you then it's for all.
Okay.
And you're not proving anything when you're doing simplify. You
Right,
just
you're
given a
just
bunch of
reducing it
simplifying.
to, you're reducing it to a hopefully equivalent expression.
Right.
Yes. So it's expression is supposed to be equivalent modulo for all things. So
Okay, fine. Okay, so here, this is Nick's new proposed proof function. Is that correct?
right.
And is this totally different from a previous
Yeah,
proof
it's totally
function?
it's totally different. It's written from scratch. It supports critical pair lemmas, and it's structured a little bit differently. But the idea essentially the same.
And how is it using? What is confirm assert doing that? So I see. So this would actually, this is using the confirm and close framework to determine if the proof is true.
Yeah. It also checks all the intermediate steps, and then at the end it checks the conclusion separately.
I don't think we
That
want
it's
the
true.
exclamation mark in the. And what does this look like right now? I mean, right now it's a function, right? That is,
Yeah.
well, this is a function as well. Can
I think currently we return true rather than success.
Maybe, but it's not gonna work. But
No, I know yours isn't going to work. This is the old one.
okay.
Okay. Now, why is yours so much shorter?
Because it's a proof by refutation. It adds,
Where-
adds a separate axiom. Tries to prove it's false.
Whereas, what's this?
And this is where it was actually not the proof that it's intended to do. It treated those variables as constants, even though it works, but
Okay. Well, so how do I do the proof that it's intended to do? Well, wait a minute.
I don't think
But
you,
you're
I don't
saying-
think you can.
Okay, but in terms of this, if I did your proof with constants, would it look the same as this or not?
Yeah, if I put an existential quantifier explicitly, then it would do the same thing.
Okay, Jonathan, this existing proof function format is yours. Can you comment on it? I mean, you're using map-ats and replaces and so on. And is there some? Okay, first question: is there something that is not doable with Jonathan's existing proof function stuff? I mean, I think it had some bugs, but in addition to that, is there anything that's fundamentally not doable with it?
With the proof
Yeah.
function?
Yeah.
Well, yeah, I mean, as documented, I mean, it doesn't support critical pair lemmas, right? It doesn't validate those.
Okay, whereas Nick is validating critical pair lemmas here.
Correct.
Is that correct?
Yeah.
Well, that's what Nick claims. I don't know that that's been independently verified.
Okay. Well, so
Nor
This
am I
is-
in a position to do that, but I think Jonathan would need to actually review it and opine on that, which as far as I know, he hasn't done.
Not yet. If the design is okayed, I'm happy to go through and review the actual change.
okay, but so I'm trying to understand. I mean, this looks rather different from Jonathan's version. So I'm trying to understand, what would you do with this code other than run it and say, great, it gives success?
Well, you still only can use it for that, but the underlying algorithms, you can use it for actual, like my FindEquationalProof path. I rewrote it to use all the changes I made so that it's much easier.
Explain. So, I mean, you're saying, go ahead. I mean, you're actually ingesting a proof function for the find replace part?
No, it's like the same like derivation of steps. Like each step, when the actual procedure for verification assumes some information about each step, and this information was missing in the original proof object because it was a pain to extract it. Right now, you actually can extract all the information without reproducing all the possible replacements, and do something more than just verifying. For example, extracting a path.
Wait a minute. You're saying from this lump of code here, you're actually going in and taking this code apart, or what?
No, I'm not taking. Well, this code is just generated once. I am not using it, but the same similar like loop over steps, and all information from the proof object is extracted to make a path, for example.
So maybe we need a lower level construct than proof function. Maybe we need that step-by-step generator of things. I mean, maybe we need that list of step-by-step functions that composes to make the full proof function.
So we'd have like a proof step object or something.
Yeah, a proof step function, or a proof step functions plural, one for each proof step. Does that make any sense, or does it need too much
Well,
common
what's the
sense?
value of giving it a function as opposed to just being able to extract a big list and then map over yourself?
Why not?
No.
Why not have each lemma be an object?
Yes, that's possible. But what would the lemma do? What does it eat? What does it? I mean, each
It's
lemma.
to other lemmas.
Yeah, just it
It's
eats
to
an
other
expression
lemmas.
and a construct and outputs another expression. Or
So you're saying, I
construct.
mean, in the way of understanding these things that we have here, for example, we have here lemma plus lemma with a particular rule of inference gives another lemma. Is that what you're proposing? That's something we don't currently have, right? Is we have only replace as a way of doing effectively a particular form of rule of inference. But we don't yet have built-in ways to do sort of take two lemmas and apply them, to each other. Is that right? But that's what we'd need, correct? In this case, if we had to take two lemmas and apply them to each other, then we would have the steps the raw material for the steps we need here. Is that correct?
Oh yeah. But those steps are pretty trivial. You just do unification and do the replacement, and that's what MultiReplace, for example, does. But for all the cases, here you just specify the actual position where this happens, and that's all the difference.
Right. But so what we need is a version of replace that does unification and that lets you give the position and does unification. Is that right?
Yeah. Well, you can also specify like a specific position in the MultiReplace. So MultiReplace actually is like all you need to reproduce each individual lemma.
Okay. Well, maybe that's what we should be using. Maybe we should, make that a top level thing. We're not going to solve this all today, and I'm about to be late again for something. So let's just take a quick look here at is there okay, so.
Yeah, so there is a main issue here, which is the current structure of proof object. I mean, when we do find equational proof of theorem, axioms, we get back a proof object with a logic, which is currently equational logic, then the theorem and the axioms again, and then proof. The whole content of the object is proof. Now, what Nick is suggesting is to change that to proof object containing an association, which contains the various fields.
As opposed to
positional arguments.
Well, right. And there
it's a minor thing, but it's important.
Yes. And there are sort of, I would say, sort of two issues. One is, I personally think, having something structural is superior because, you can test things more easily without evaluation. People can disagree on that point. But the other thing is, in his implementation, he's made no provision for old style proof objects, which means anybody who has a proof object stored in their notebooks or whatever.
Yeah, that's not going to work. It's not going to work. I mean, so what you're saying, Itai, which I think I agree with, is you like the direction that Nick's thing is going, but there needs to be a bridge to the past.
I'm not so hot on the direction he's going in, but I won't go so far as to claim it's absolutely wrong, but there absolutely has to be a bridge to the past.
Yeah.
I want to bring up another point, which is that the synthetic geometry prover is using the old proof object structure.
Right. And
that's not obviously compatible with this association format, because, for instance, in a synthetic geometry proof, there aren't constants and variables.
It's not a very big problem. It's just a part versus a key. It's literally 1 minute change. But the point is here is that all the old proof object is already broken. And you still have to regenerate the proof if you want to get the old proof object to work. It's like all that works is the dependency graph. Besides that, the proof itself is unusable.
Right. Well, then you could have something that evaluates the old form into the new form with the new proof.
That I already have. Like if you have a proof object, old style proof object, if you evaluate it, you get a new one. It just regenerates all the proof from scratch.
So what was the?
So it'll take a much longer time than you might expect, though, because it'll actually do a proof.
Yeah, but that's not the worst thing in the world. I mean, so you're saying, but okay, what's the story with the synthetic geometry prover? Because that has to be tracked down. I don't think there's anybody in this meeting who knows, unless Ian, do you know about that?
Well, I know about it. And they're certainly not ready for 13.1. They might release it as a packlet after 13.1 is out.
Okay, and
we had certain hooks for them so that they could reuse proof object with their slightly different stuff, and that's where I think the advantage of having something positional arguments, then it's very easy to sort of evaluationlessly pattern match against the structure and say, oh, I'm going to go down this code path because this is a synthetic geometry proof rather than a
Okay, I would argue differently, which is that if these proofs have very different kinds of things in them, then it's much better to have an association.
It's the fourth argument that is different. So the structure of type of logic theorem axioms is the same. And that's the information that's needed, for example, for typesetting. So you can use it without evaluation. While the new method will have to go through evaluation, and so it's potentially a source of evaluation leaks.
I don't think you have to. You just wrap it around with appropriate amount of unvalidated. And the association is never related.
It gets more complicated. So, I mean, we can't keep the same 4 arguments structure, and then you have full freedom in the 4th to put associations and everything you want there.
Nick, what do you think?
I mean, I think it's pretty typical that you have at least like one argument at the beginning that's like, what kind of object is this? And then after that, maybe you have an association. I mean, in this case, maybe it's in the 4th position or something.
If we think that this will always be a type of logic, an axioms, I'm sorry, what's actually next? It's theorems next, and then axioms. Is that right?
Yes, same order as in the constructor, FindEquationalProof.
Nick, what is your objection to having the first 3 arguments like that, and then in the 4th argument having an association?
Well, my objection was that it's not always the case, I think. It's like, for example, theorems can be dropped. For example, I can make a proof object that just generated by completion. You just give it an axiom and generates a bunch of theorems without you specifying an exact goal that you want to reach, right?
Does FindEquationalProof support that?
I have a function that just makes a completion already. That constructs the same proof object without a theorem. Well, you could put all the theorems that it proved or found in a list of theorems, but it's not the theorem that you specify. You just specify a list of axioms, like the thing you.
No, I get it.
Theory.
Right, I get it, but I mean that's a different thing than FindEquationalProof, which is find a proof of this particular theorem.
But yeah,
In
but
fact,
it's not a
that's-
find equation proof. It's a proof object we are discussing. So
I
it's
know
the
that.
same
I
proof
know that.
object.
Yeah, I understand that. I understand that. But the question of whether the proof object says automatic or all in that position doesn't seem to me, that doesn't seem critical to me. Okay, we're not going to resolve this right now. We're going to have to bring this back. Sorry, we got lost in the trees here for a while. And
All right. Well, I think that'll, I presume we won't discuss this for another week or two. And I'll try to take a look at because Nick has made some updates since the last time I looked at his PR. So,
okay, is it possible to just outright fix the bugs without introducing this new format? Nick?
Yeah. The format is trivial to change. It's just
Okay, so fine. So let's look for 13.1. Let's try and fix the bugs and not change the format. And then for 13.2, let's revisit some new functions, MultiReplace, and those things, and try and actually sort of get this right. But for this version, let's just make sure we fix the bugs.
okay.
And all right, I have to go. For those following these live streams, I'm actually about to do another live stream about history of science and technology. But good. Thank you all very much. See you later from here.